All right, everybody, welcome back. We're going to evaluate these expressions. What we were doing in the last video, but now we're just going to take a little step further. We're going to do it with a fraction. It's no big deal. Because remember, the exponents with fractions, they both of these numbers, numerator and denominator, go to the 2/3 power. Now, these numbers are picked specifically because they work out. Now, do you recognize 125? It is 5 to the third. And if you're not sure why, just go ahead and figure it out on the side. Now 216. We haven't dealt with 216 yet. My guess is, I don't know. Why bother guessing? Let's figure it out. So half of 216 is 108. And let's see, a 2. Yeah, so 54. And a 54 would be, what do we got? 9 times 6, right? So we have a 3 and a 3 and a 2 and a 3. So what do we got? We got 1, 2, 3. 1, 2, 3. Okay. So this is 2 cubed times 3 cubed. Well, I figured they all had to be cubes because, it had to work out with the cube because we have 2 over 3. So we take each of these and raise it to the 2/3 power. So that's all we're going to do is each of these. So we're going to take 5 to the third, raise it to the 2/3 power. When you raise a power to a power, you multiply. So what is 3 times 2/3? Well, it's 2, because 3 times 2 is 6. 6 divided by 3 is 2. Okay, that's what that becomes. Now, we're going to do this one. 2 to the third raised to the 2/3 power. Same thing. It's going to be squared because 3 times 2 is 6. 6 divided by 3 is 2. So it's going to be 2 squared. And the same thing is going to happen to 3. 3 squared. Because 3 times 2 is 6. 6 divided by 3 is 2. That's why we have 3 squared. So that's what these all become. 5 squared is 25. 2 squared is 4. 3 squared is 9. This answer will be 25 over 36. Can't be reduced, so that's a fine, fine answer. All right, we'll get rid of our notes here. And we'll push these over a little bit so they're not in the way. All right. Oh, these are already broken up individually. Oh, that's good. So, 64. How can you rewrite 64? 64, again, is one of those numbers you recognize. And we did 64 before, didn't we? Let's see. It's 2. 2, 4, 8, 16, 32, 64. 2 to the 6th. Kind of thought that would have to be divisible by 3. All right. So that's going to be to the 2/3 power. Now 343. What's that one? I bet you we can divide that by 7. I'm going to give it a shot here. 343 divided by 7. Yeah, guess what? It's 7 to the 3rd power. I kind of recognize that as a possibility, but it didn't come naturally. I had to put it on my calculator and figure it out. But that's what it is. Well, now that's good because now we just take it to the exponents. So 6 times 2/3. So it's 12. 12 divided by 3 is 4. 7. 3 times 2 is 6. 6 divided by 3 is 2. It's 7 squared. Well, that's 16 over 49. All right. What's about this one? Well, let's do each one individually. So, what is 25 to the 1/2 power? You might just know it off the top of your head because doesn't this mean square root of 25? This is 5. If you're not sure, that's okay, because we're just working through these. 25 is really 5 to the second power. Raise that to the 1/2 power. 2 times a half is 1, so you have 5. All right, here's our negative 64, but again, it's a cube, so we're okay. And it's a 1/3, and it's a negative 1/3. What does all that do? All right, let's do piece at a time. So what would 64 break down into? No, we just did 64 last, 2 to the 6th power. All right, it's going to be to the negative 1/3. Okay. Now let's look. Will we have a negative answer? So I'm going to take a cube of a negative, which will be a negative. I'm going to take a negative to the 1st power, which is still going to be negative. That's going to be a negative answer. What is 6 times negative 1/3? So the negative will stay there, but 6 times 1 is 6. 6 divided by 3 is 2. So this is really 2 to the negative 2 power. All right, how does that translate? What does that mean? Well, if you remember, a negative exponent will make this, we'll flip it. Okay, a negative exponent makes this over 2 squared. Okay. This 5 stays on top. This negative just goes somewhere. It can go at the top, can go at the bottom, can go on the outside. Just remember your answer has to be negative. And what is 2 squared? It's 4. So that reduces to negative 5 over 4. Alrighty. So that one was a little bit more challenging, but just piece by piece. Figure out this one. Figure out this one. And they threw a couple negatives at you on that one, a negative 64 and a negative 1/3. But you know what those mean. You know how to work them. So just be careful and work them through. And if you want to double check your answer, put it on a calculator, check it. Now, if you put this in the calculator exactly the way you saw it, you will get that answer. Okay. That's how they work. All right, sometimes I enjoy simplifying expressions with variables better because you don't have to reduce anything. So look what we're doing here. We have g to the 4/7 times g to the 3/7. Well, we're going to add those exponents. What's 4/7 plus 3/7? Yeah, 7 over 7, which is 1. So our answer is just g. So nice. So nice. Same thing here. Same base. Add the exponents. So 3 plus 13 is 16 over 4. What's 16 divided by 4? 4. Oh, my least favorite variable, s, but it's s to the 4th. Powers to powers, you multiply. What's 1/3 times 4/5? Well, we multiply fractions. They're easy. 1 times 4 is 4. 5 times 3 is 15. You can't reduce that at all, so I'm just going to write a little bit differently out here. It's u to the 4 over 15. Nothing else you can do with that. All right. There we go. All right. Simplify each expression. Now, remember that it doesn't say write in radical form, so we're going to leave them with fractional exponents. But when we say simplify, we have to remember what these mean. That's b to the negative 3/5. So it means I've got 3/5 on the bottom. Now, I actually don't like this problem very much at all, because remember that one rule for simplification is you cannot have a radical in the denominator, and technically, isn't this a disguised radical? Isn't this really the 5th root of b cubed? So we're not allowed to have that. So what's wrong with just leaving it b to the negative 3/5? Well, I don't have a technical problem with leaving it that way, but mathematical convention says you don't want to leave your answers with a negative um, exponent, and you don't want to have radicals in the denominator. Great. So here's the weird one. How can I make the denominator not have a root? Now, if you think about it, it's really not that difficult, because what would I have to multiply this by to get the b not have a root anymore? Well, I'm going to put this on there and see what you guys think. If I multiply b to the 3/5 times b to the 2/5, what happens with these? When you add them together, what's 3/5 plus 2/5? Well, it's 5/5, which is 1. So now we just have a b on the bottom with no exponent. Now, again, we just can't decide to multiply the bottom by b to the 2/5. We got to multiply by that great number 1. This is a fancy way of writing number 1. So what's 1 times b to the 2/5? B to the 2/5. So this is a way of rewriting that equation, or rewriting that expression, and not have a root in the denominator. Now, if you really think about it, if this is b to the first power, what's 2/5 minus 1? Remember, when you divide, you subtract the exponents. 2/5 minus 1 is negative 3/5. So the answer is correct. These two are the same. And this is written without a negative and without a root in the bottom. So take that for what it is. It's not my favorite kind of problem, but that's the way they expect us to do it. This one looks a little bit easier because we're just dividing. So if we divide, what do we do with the exponents? We just subtract them. So this is q. We'd have 3/5 minus 2/5. Oops, that's a minus there. So 3/5 minus 2/5 is q to the 1/5. Oh, q, my goodness. Getting all my letters jumbled together. Q to the 1/5. All right. It's not negative. It's not in the denominator, so it's good. All right, and now this problem, probably the weirdest of the bunch. Okay. Look what we have in the bottom. We've got that root. So we actually did problems like these before. I don't know if you remember it from the last one, because isn't z to the 1/2 really the square root of z? And remember how we got rid of that square root of z on the bottom? We multiplied by its conjugate. Now we're going to do the same thing, but we're going to do it with the rational exponents. So when it's done, we don't want to have any fractional roots at the bottom or negative roots in the bottom. Okay. So just like last section, we multiply by the conjugate. Okay. So this is going to actually turn out to be a very nice number, and you'll see why. At least not a nice number, at least all the exponents will be gone. So let's multiply the top. Now remember, it is going to be, these are together, this is it's only 1, so we just distribute this through. What's 2z to the 1/2 times z to the 1/2? Well, it's 2, and you have z to the 1/2 times z to the 1/2. Well, you add the exponents. What's 1/2 plus 1/2? 1. So it's just 2z. And now what's 2z to the 1/2 times 1? It's 2z to the 1/2. That's the numerator. Now the denominator. Move that down a little bit. We got to do FOIL. What's z to the 1/2 times z to the 1/2? When you multiply, you add the exponents. So it's z to the first power, because 1/2 plus 1/2 is 1. And now we do z to the 1/2 times positive 1. Now we do -1 times z to the 1/2. And that's what we wanted to happen, because what's going to happen to these two terms? They're going to be 0. And what's -1 times +1? -1. All right, we can't do anything to the top. Can't combine them. But the bottom, or that becomes 0, which is z minus 1. I know it's weird. I know that's crazy. And like, why are we doing all that? It doesn't seem to make any sense. It's very helpful going forward with some problems that you do in higher math classes. All right, simplify these expressions. Now, really we're learning how to manipulate these things and turn them into something else. If it says simplify and it starts with a radical, you probably want to give the answer as a radical, as opposed to these where it started with a rational exponent, so you want to leave your answers with rational exponents. Just a little rule of thumb to follow. So if I want to simplify this, I eventually want it to be something with a radical. Now, you might notice if I have this, the 10th root is to the 5th power to the 10th root. So really it means 8 to the 1/2. Well, 8 to the 1/2 means the square root of 8. And now how do you simplify that? And we've done this a million times. Remember that 8 can be broken up into, well, it's 2 cubed. All right. And the same thing we always would simplify it by. If I've got a square root, so I divide to simplify this. How many times does 2 go into 3? It goes in once. So 1, 2 escapes the radical with a remainder of 1. So 1, 2 stays in the radical. So that's 2 roots of 2. And again, it's a root. I'm going to leave it as a root when we're done. Now we got to simplify this a little bit. So what would the best way to do this? Let's see. Let's take it 12 to the 1/2 times 12 to the 3/5. All right, so we can multiply these together because we have a 12. But when we multiply, we have to add these exponents. Well, we can't add the exponents. Well, we can, but 1/2 plus 3/5, we need a common denominator. So what if the common denominator between 2 and 5 would be 10? So could I change that to 2 to the 5/10? I'm sorry, 12 to the 5/10 and 12 to the 6/10, which means I've got 12 to the 11/10. So if I put that back in the radical form, this is what I have. Now, how would I simplify that? Well, the same thing we do here. If I want to escape the 10th, the 10th root radical jail, how many times does 10 go into 11? Well, 1. So 1/12 comes out. And what's my remainder? Well, I have 1 as a remainder, because 11 divided by 10 is 1 with a remainder of 1. So that is how we reduce that. All right. What's the problem with this one? It's got a radical in the denominator. We don't want a radical. Now, luckily, it's a root. It's a square root. So we just multiply it by itself, and that gets rid of the square root. So the numerator is a times the square root of 3b. The denominator is the square root of 3b times the square root of 3b, which is 3b. No negative exponents in the denominator, no radicals in the denominator, so this is the answer. So the question is a tough one. How do you know when to simplify what you want the form to be? Good news for me is that I will give you multiple choice answers. So I want you to turn one into the other. When you get to pre-calc next year, there's going to be scenarios where you want it to be a certain answer. So as long as you know how to manipulate these numbers and make them however you want, that's what you want to do. It's like a video game. Some people are so great at video games because they see all these possibilities and man, they can manipulate that controller. Like I loved playing Madden when it came out, but it was nice and easy. Madden only had a few buttons to choose from because the controllers were much less advanced. Now you've got X, Y, A, B. Depending on your game system, you got 4 buttons, you got 2 control sticks, you got these things here. It's almost too much for me. I don't know how to use them all. So now if I play Madden, I get killed now because I don't manipulate the buttons as well as I used to. This is all that is. You're manipulating these numbers to turn them into anything you want. That's the key of mathematics and the beauty of it. You get to manipulate them. Now, the frustrating part of mathematics is I tell you what I want you to do. So, all right, last problem. Nice, easy one, honestly, because all we're just going to do is plug this into the formula. We have this formula that calculates current. Now, I don't know much about electrical studies. I don't know why current is I, but it is. Okay, so we're given information. P is the power in watts. R is the resistance. P is 500. So even if I don't understand what it all means, I know how to run a formula, which you're going to find is actually quite a good skill in life. R is 10. You just have to accept the fact that the formula is correct. All right, so 500 divided by 10 is 50. So it's 50 to the 1/2 power. And we want to round it into the nearest 10, so really this is just the square root of 50. And it's a little bit above, so it's 7.1 amps. Now I don't have that memorized, it's just 50 is really close to 49. So I figured it was 7.1, and then I looked over at the end, threw over on the other screen, it is 7.1. Alrighty, so the big thing about this one, honestly, is just understanding this. That a rational exponent can be rewritten as a radical and vice versa. And then you open up a whole new world of possibilities for simplifying them. Keep it up, keep the positive work going, and let me know if you need any help. In the meantime, good luck with this, and have a good day.